So some of the problems that this talk is hopefully going to help you solve is dealing with team members with different environments. Maybe they have some people on Mac, some people on Linux machines, some people on Windows, or even just different versions of things, or any number of possibilities. Maybe this talk can help you solve that. Dealing with new team members, you need to get them onboarded quickly as possible so they don't spend a day or more trying to get their local development environment set up so they can get started. That's a huge pain too, as well as just standardizing what you're using for your development process. The tool I'm talking about is Nix. So when you talk about Nix, you have to understand that it's three different things. So first of all, Nix is a functional programming language, much like Clojure, Scala, Lisp, and things like that. It's also a cross-platform package manager, and it's a full-blown Linux distribution, which I am running here on this machine. So to kind of go from the different examples, so Nix as an operating system. So it has a lot of advantages. One is it's considered to be the grandfather of modern, I know the term's not really kind of being shunned upon, but it's a grandfather of what's called immutable distros. So whenever you don't make a change to the actual system, you make a change to a system that you're building and that you boot into next. What this means is whenever I reboot my machines, I get prompted with a grub menu or the systemd boot menu, and it has a list of every version of my operating system, and I can choose which one. This gives me advantages. So say I make a change to my local config, rebuild it, try to reboot, or I realize something's broken, I can just boot into an older version of my system and be able to fix it from there. Another thing is it allows for easily being testable. So instead of having to cross your fingers and hope that something works or did what you want, you can use Nix to build a VM using QEMU and KVM, and it will boot a virtual machine that has your configuration the way you have it, so you can see if it's going to work, see if your changes are the way you want them to be. And because of this, I do consider it to be the embodiment of what infrastructure of code can and should be. It's to the point where if you go to this URL and clone my Nix configs, you can actually rebuild and reproduce my laptop here all the way from how my disk images are partitioned. So all my hard drives, all the way up to the installed packages I have here, to even the look and feel of my computer. But Nix as a package manager goes even further than that. So it handles not only installing, updating, and uninstalling packages, but it also handles configuration. So you can install, say, Apache and configure Apache all in the same spot. The same file, the same configuration, it's all just there. And also it utilizes isolation. So those who's a Unix graybeard will know how the file system of a traditional Unix system is supposed to look. You have things that go into /etc for configuration. Your actual programs you install will go under the user directory, and you have all these others. Where Nix kind of breaks that in for a good way. So with Nix, everything goes under a /nix directory, and it's what's called the store. You have the package store, and everything is hashed. So this allows for a couple of different things. So first of all, it allows you to have multiple versions. So say you install PHP 8. You can have PHP 8, you can have PHP 8.1, 8.2, 8.3, all installed together, side by side, not conflicting with each other, and be able to reference them. It can also handle installing dependencies directly. So to show what I mean there, if I switch over to a terminal, right now, I don't have PHP installed. No So no composer either. Go is not installed. No Rust. But if I launch my NeoVim and open a terminal here, now I have PHP. All just by opening up my text editor. Same for Go. And same for Rust. That's all it took. And the way that works is because in my Nix configuration, I told it every time it builds NeoVim to install those packages as a dependency to NeoVim. So they're accessible here, but not to the rest of my system. So if I close out here, they go back to not being installed. You're also able to, because of how it works, you're also able to manipulate, you're able to change how things are done. And I'll show an example of that here in configurations in a minute. And one cool feature, and gets into what helps this talk, is the ability to create a temporary environment or an imperative shell. These are shell environments that have packages installed or configurations installed that are specific to that one location. And well, that's the core of what this talk is. So, using Nix as a package manager, this is how you define what should be installed. You basically just tell it, I want you to make sure that Firefox is installed, or that Git's installed, or NeoVim is installed. And then next time you rebuild your system, it's going to make sure it's there. And if you need to remove a package, say we don't want NeoVim anymore, it's just a matter of removing it from this list and rebuilding the system. And NeoVim won't be there anymore. Another cool thing about Nix is because it's a functional language and the way it works, you can define what's called multiple channels. So you can have one channel that is your base. So you can have either the stable, which follows the traditional Linux distro release cycle where you have a release twice a year, or you can have unstable, which is rolling release. Here we're saying install the Firefox package from the stable, what we have is defined as the stable channel, whereas Git and NeoVim will be unstable, so they'll be just the latest versions packaged. So you can mix and match. This comes in really handy, especially in my use case, because being an Arch user, most of my system follows the rolling release version. But say they push an update to something and it's broken, I can just go into my configuration and have it install the version from the stable channel until it gets fixed. And here's another example of installing OpenSSH and also configuring it. So here we're saying to install OpenSSH, make sure it's enabled at boot, go ahead and open port 22 in our firewall, and set these configuration options so that it won't allow password authentication and it won't allow root user to log in. So when you rebuild, it will have all of this, and you can go from there. And here's an example of overrides. So on this top line here, I have this packages nerdfont.override. I'm saying instead of installing every font that the nerdfonts package gives me, just install this Go Mono font. Now, as far as an imperative shell goes, so as I said, these make environments reproducible because because of the way it works, you can define them in a Nix file and then give it to someone or put it as part of your version control. And when they check out your Git repository or your Mercurial or whatever you're using, they have everything needed to create it. It can take less disk space than Docker and several other tools because of how because if you already have it installed, instead of reinstalling it, the Nix store is just going to hard link. They're easier to manage, and you can create a shell on the fly. So in this example, what I'm saying is from this Nix PKG repo, install this package hello. So we have it here. And there's also another syntax. So let's say we want to do neofetch. So you can also use this syntax, which will go ahead and install this package here and run this command that's part of it. So, if I can type right. So even though I don't have neofetch actually installed, or I didn't until now, it created that environment and went ahead and installed it and ran neofetch for me. So at this point, you're probably also thinking, couldn't Linux containers solve a lot of this as well? Sure, they can help ensure a common environment for your developers. They can help speed up the process for onboarding new people into your team. But containers are not reproducible. Even though you may have it pinned so it's going to pull, say, use the Ubuntu 2024.04 base image, unless that base image is never getting updated, keeping up with security updates, things can be different between the version of the container you have and the one the new person just spins up. And also, if you do need to use things like Docker, Podman, Kubernetes, or whatever, you can use Nix to create those images. So you can have your environment be reproducible and then build your image that you then go and deploy using those container engines. Okay, this one might be a little messy here. Okay, but the way that Nix ensures reproducibility is that it's basically, since it's a functional programming language, it's a collection of what's called inputs and outputs. Your inputs are basically where it's going to pull things from. So think of it like package repositories, but it's much more than that because you can also have modules. So like this disco module, that helps define how it does partitioning. So you can just script out how you want your disk partitioned. You have impermanence, which is a module that will make it possible to where every time you reboot your system, you get a clean installation. So like how my systems are set up, every time I reboot, the file system actually gets reset to a point to where there's nothing on the file system, and then during the boot process, it just doesn't install for me. You have a collection of hardware configurations. There's one that allows you to declaratively write, which is how if you clone my system here, everything will look the same because I'm using this stylix. And then much more. And whereas your outputs are basically what defines how that system is created. Let's see here. Well, that's not good. All right. So one of the ways that makes things easier is what's called a flake. You can think of flakes much like how Composer or other tools like that works, where you have one file that defines what should be installed, how things should work, and then you have a lock file which ensures that dependencies are all at the same version. Nix and Nix Flakes works that same way. So with Nix, you have the flake.nix file where all of your configuration, everything goes, and then you have the lock file which will have the commit hash. So it says, go to this repository here, check out this commit. It should have this checksum here to make sure that it is what it was when you originally checked it out, make sure that no one man in the middle or anything like that. And you can have your flakes be monolithic or they can be even modular. So to kind of show how some of this stuff works in production, as far as the flakes and everything goes, I do have a couple of demos here. So first, I will start with a more simple. So here, you can see here I have my flake nix and flake lock file. And in the flake.nix, all I'm basically doing is telling it I want it to install Hugo, which is a static site generator built in Go. So then this site can be built. Well, right now, I don't have Hugo installed, but if I go to Nix develop, it's going to go through, and now it's installing Hugo for me because I let it garbage collect, so now it's going to have to reinstall it. But now Hugo is installed, and I was able to build my site here. All just by doing a simple command. And if you go and check out this Git repo, which is public, you can do the same with Nix. But you can also even automate some of that. So let me go show an example here. So this one I have set up to where whenever I cd into this directory, it's going to go ahead and automatically run everything, build out my development environment, and drop me into it, which is what you saw here in this very quick output. So basically, it's going through, loading the environment, making sure everything got installed, set up all my necessary environment variables. But here, now I have Go installed when I didn't, because this is a Go-based project. And I can be able to run it. And this one is actually using a little different. So this is using a tool built around Nix called dependency. And the configuration for that is a little different, but it allows for even more power. So let me come into here. Now, one of the big things that this tool helps with is it makes it even possible to do things like managing database services. So here, I'm telling it to also install Postgres. And this will not only installs it, but sets it up to where all the databases and everything gets installed local to this directory. So I can have this one and another project both using Postgres, and they're not able to see each other's databases because as far as they're concerned, it's the first time you run it, it's going to be a clean environment. It's going to initialize a new database and set everything up for you there. But to do that, so this dependency will run everything. If you do dependency up, it's going to go through. It'll build everything, and then it'll go ahead and start all my running services. So let it build here. And now you see that I have Postgres, it's running and it's ready. There's Air, which is a tool that will, for Golang, it will, as you make modifications, it'll detect it and automatically restart your web server. And it's all up. So if I was to come over to here, and it's 3,000 on this here. And there's the app, although I don't know why it is being janky and in that lower. Yeah. The demo gods.
Demo. Most of it's working. You've already beat
Yeah, the demo gods are trying to interfere with my reproducible environment here, but yeah, there's the app. And to prove that it truly is because of this, let me go ahead and tell it to quit. So it's going to shut everything down, and the site's gone. And we're back to even Postgres is not even running. So if I come into here, and I think it installed into this database. Yeah, it can't connect because I shut it down. Even Postgres isn't running now. And let's see here. Because this is a Drupal, I do have a Drupal example. This one is a little bit more, even more involved because I have more services set up. But what we're basically saying here is first we want to make sure that Git is installed, and then we're installing PHP at version 8.3. We are setting up PHP FPM, so then we have that running to be able to serve our files. We are setting up Caddy as our web server, and it's going to be listening at port 8080, and it's going to just reverse proxy everything to port 9000, which is what we have FPM set to listen to. And we have Postgres version 16 set up, and it is going to listen on localhost. And when you initialize it for the first time, it's going to go ahead and create an empty database called DCChaw 2024. So if we come into here, dev-env up, you can see we have Caddy running, and we have PHP FPM running, and we have Postgres running. So if we switch over to here, do a little bit of that, hey, we have Drupal 11 installed. And just to prove that I'm not lying to you, I'll go ahead and shut down everything here. And
liar.
But
your screen changes to the 1980s.
yeah, it's this exploding Windows affecting KDE.
Does my ADHD wonders?
But yeah, so you can even go as far as doing that. So I did go ahead and set up the database. Otherwise, when you first went to the port 8080, Drupal is just going to have you do the install. So it's going to want you to select the profile and configure how it's going to talk to the database. I went ahead and did all that. But if you were to clone this repo, and I'll give you the URLs at the end of the slide, you'll have to do that yourself. But Nix will set up and make sure everything's installed and get everything set up otherwise for you. So that is it for my talk. And as I said, so my personal repository, which defines how this system's set up, my Pinebook Pro setup, my Chromebook setup, my home lab server setup, it's all done in the same config. And as far as the other URLs, it's all just, if you come into GitLab, or not GitLab, but SourceHut here. So here's the repo for that Drupal site that I just showed. So if you just git.sr.ht /Vindion DCChaw 2024, you'll be able to then clone it and have everything here needed to set up everything. Nothing fancy since it's just a base Drupal install. And here's my Nix configs. Oh, thank you very much. And at this point, yes, questions?
So you're a little bit over my head and esoteric, but you're telling me that I could have a machine set up with different directories, sharing essentially the same tools but completely different configs. As I change into the directory, I would have that other project running, right?
Yes.
And
So
not bumping into each other.
yes.
Okay.
So
I just want to make sure I got that right. That I can do that.
So the way it handles that is this dev-env tool at the root of your project when you first start it.
Yeah.
It creates this .dev-env directory, and then when you tell it to start like database of Postgres, MySQL, anything that's going to need persistent data, it's going to set that directory to be that data store. Okay. So everything there can be localized to this project directory. So I can have this one here, so I can have this one up and running, and then I can have another one running that's also going to have a Postgres database. The problem that you'll run into there is your ports, and in your Nix config, you just say this one's going to run at the default port for MySQL, and then you define another port for the other project.
Okay.
And actually, I don't have that defined in here, I don't
No, that's all
think.
right. I just want to make sure that that's what I caught out of that was.
Yeah, so like, if we wanted to, we could say in here, instead of being on the default 5432 port for Postgres, we can say run it at this port. And that's how you can avoid that. But this won't see the data in the other project.
Right.
Because it's all just localized. It's not true isolation, though, because it's not like running a CH root or anything like that. So it's not a security, but it'll at least...
I set up a different virtual machine for each crazy project so that, because they don't coexist.
Yeah.
So it's nice.
Yes.
So first off, thanks for showing us this. This looks like really cool. I'm gonna try this out. I normally solve the same problem with developer environments with Docker Compose. So what are the benefits of using dev-env over Docker Compose for like getting your dev tools stacked, both like the SQL servers and whatnot?
So again, this the way it works. So Docker, not reproducible. So say you've been working on the project for a while, you went ahead and pulled that image, and then say I jump in on it, I'm going to work on something, and so I go ahead and pull down everything, I run Docker Compose, and it pulls down the image, whatever you're using. My image may have newer versions of packages and everything installed that yours does, which go ahead and breaks, that alone breaks reproducibility. Whereas here, that is guaranteed because, no, not Composer. Getting the wrong files. So in this lock file, just like how Composer works, it's going to say for whatever repo, so let me pull the Nix packages. Yeah, so for Nix packages, it is going to pull this commit. So when I run it, and if you go pull this and you run it, because it's pointing to that same commit SHA, we're going to have exactly the same packages down to the exact bug fix version of everything. Okay. That's where we get the reproducibility from, is this ensures that I have the same version you have. Because another example, you may be running PHP 8.3.4, and then I come in, install PHP, and the latest version is now 8.3.5. So I install that. Now we have different versions of PHP. Things can be different because there's a reason there's that bug fix. They changed something in how the language works. and it could cause a problem. Now, I did actually run into this. I was working on a project before, and they were using ddev to manage everything, so they would have a Docker container. When I joined the team, the guys told me that they were using ddev, so I just went ahead and pulled down ddev. But when I was trying to run things, things were broken. And it took hours of debugging, including even deleting the Docker images, letting it pull the new Docker images down, and getting the exact same result, only to find out I had a newer version of ddev installed than everyone else on the team, which resulted in me having a different Debian version because they were using Debian 11, and my version of ddev was pulling down Debian 12. And one of the dependency packages had a name change. So the apt install scripts during the Docker build was failing always. This would solve that. And then as far as running Docker, as I said, you can use this to build a Docker image. So once you have your environment set up and running and know that everyone can get it, and say you're using Kubernetes in production or something, you need to deploy an image. You can use Nix or Debian to generate that image and deploy that.
In theory, you could even use this as a wrapper around your Docker and Docker Compose. If you're using that as a dev.
Yeah, because this can build that image that you then use in your Docker environment.
With this, with Debian. It looks like
With both. You can use just plain Nix or you can use Debian. Debian is just a wrapper around a lot of Nix and makes things easier. So let me see here. Because I think, yeah. You can just do Debian container and build an image.
okay. So when you were running Postgres there, that was pulling Postgres down to your local machine. And I suppose if you were to run this on the Windows machine, it would do the same thing?
For Windows, you'd have to use the Windows subsystem for Linux, but yes, it will do the exact same thing.
Okay, so this is only going to work on Linux? Or maybe
No, Nix runs on Linux, Mac OS, and BSDs. And because Windows has that subsystem for Linux, it can run on Windows.
Oh, I'm sorry.
Yeah, Unix environments are more friendly when it comes to developers than Windows does.
Very cool.
The way to get Windows developers in a real environment is WSL2.
Yeah.
You're using Unix, you just don't know it.
Facts.
Here's a nickel kid, get yourself a better computer.
Look, I will not take all the slander against my Windows PC.
It's all right. You'll come to these enough and realise I've either got Mac or Linux. Everyone's got Mac or Linux.
I have already.
And like one or two Windows guys are having trouble.
Yeah.
And you realise,
Yeah, I'm already planning on getting a Mac.
This is very cool. Thank you.